Site 2, the QUT Ferry Terminal. Okay, the extent being, it's actually broken into 3 components. So the first part is looking at the front entry part. So that includes the sign. Let's understand what that's made of, mild steel in this case, powder coated, how it's actually fixed to the concrete substrate, what the retaining wall is on the far side there, the hot dip galvanized steel hand railing, understand there's forces on that handrail, the off-the-shelf drink fountain, the stainless steel hand railing here, the casts are potentially precast. We need to check that. It actually could be cast in situ concrete pillars, the powder coated mild steel balustrade, which has a very interesting structural system to resist the cantilevering force. Understand the expansion joints. Mild steel expands and contracts a lot when we consider the operating temperatures can be as low as say 5 degrees and can go up to around 40 degrees. Not necessarily in one day, but nevertheless we have to design for expansion and contraction. How the stainless steel handrail is connected to the mild steel powder coated balustrade. So the extent here, and we will also include the signage, what it's made of, how well it's performing. We'll go up to this section here. So imagine a line perpendicular to the axis of the walkway which covers this entry part. There's a few other elements. Don't worry about the vertical light. Look at the surface finish of the ramp itself. Look at the range of materials. Consider what's precast, what's not precast. Look at the materials of the tactile paving in this instance. Look at the maintenance, look at the DDA compliance. For example, this is greater than a 5mm vertical change in level, i.e. that's a trip hazard. So now going to the second of 3 parts. Hopefully this temporary balustrading is gone by the time you're doing this. We're looking at this change in direction of the main ramp. So we're looking at just this area here. We're not looking at the new pretty poorly matched hand railing and walkways on either side. We're looking at these elements, how they're fixed and what they're fixed to. We're understanding why the balustrade goes up in height for DDA compliance. Hint, it's related to the seat. We've already covered the detail, but draw this anyway. So we're measuring the heights of all of these elements. Understand how the expansion joint is working here and what the materials are in these different elements, and the broom finish on the concrete. So we've actually got a silicon expansion joint here, a pretty substantial one. What's that, about 60 to 70 millimeters wide? That's a fairly serious expansion joint. So the extent of this second part is up to here, and then back to just the other side of the new walkways that go either side. So that's number 2. And then the third section, again we're not doing the lights, is we're looking at this signage element here. So a lot of this is actually repeated. Don't get caught up with the architecture, but I want you to study and measure this signage element. It's quite interesting. Look at the different materials, the coloured glass, the folded mild steel, folded and welded mild steel, the signage. So draw up this section of mild steel look at the power supply, just locate this vertical element, but stop the extent of your drawing just to the top of this level. So we're not doing the architecture, we're treating this as a landscape project, and we're only going up to the doorway here of the main ferry terminal. That's the extent of Site 3. There's a lot of very interesting things to learn in studying this element, the lighting, what is achievable as far as sort of plastic forms with mild steel. And understanding the actual surface coatings to give this thing some durability. Okay, that's the extent of Site 2.